Hey everyone, nice that you still come to this last talk today. My talk is going to be about crafting reactive apps with the Realm mobile platform, unlike what's officially on the schedule, because back then, when I was invited to the conference and should give the topic of my talk, the Realm mobile platform wasn't even announced yet. And so I was unable to spoil any details because we have a larger press embargo and want to have a big release around that. So that was only like 2-3 weeks ago. The time was passed by quite quickly for us involved into the product development. But it will be still also about Realm and what you might have expected from just a shorter talk title. But for the beginning, I want to make a quick poll to get a better impression the audience. Who has heard before about Realm? May I take a picture? Can you? Marketing will be really happy to see so many hands raised. Okay, and next one. Who has played around with Realm? That's still quite a lot. And this one is more difficult. Who has shipped an app with Realm? Okay, so you're still working on it. Nice. So, okay. Nice that you all have heard already about it. I'm pretty sure I still can tell you something new. But let's speak about the first aspect of the talk title, the reactive part. What does it mean that something is reactive? So there's a manifesto in the internet what building reactive apps means, and it consists out of 4 attributes they have to fulfill. They should be responsive, which means they should update their UI for mobile apps as soon as there's new data. They shouldn't be blocking, so you should be always able to interact with it. They should be resilient, so they should work without an internet connection, for example. And they should be elastic, which means for us specifically, we reach this goal by our concept of lazy objects and 0 copies to be super efficient. And they should be event-driven, as you might all knew from working with reactive APIs. And specific for Realm, this is also true for the atomicity of the objects and transactions. So in that way, you have a very message-driven, event-driven concept. And we will, over the talk, learn a bit more how Realm is in various ways very reactive. And so you will learn that you don't need even reactive Cocoa, ARX Swift, ARX Java, Reactkit, however they are called. There are lots of reactive frameworks out there. But to build an app on a reactive architecture, you don't need to follow one specific API philosophy of a specific framework and build your app all around that. It's a bigger topic, but you can be still freely use them also with Realm or on their own to build reactive apps. So to begin, what we had so far as our product is the Realm mobile database. The Realm mobile database is available on the platforms iOS and Android via the native platform language, so that's Java, Objective-C, and what was Swift. Since it was launched, like basically the day it was launched, or soon after that, when it was stable, we already were able to support it. But in I think the last year, we also launched bindings for React Native and Xamarin. So you can even use cross-platform development technologies to build your apps using Realm. And it already powers several top 100 applications. And we are proud working together with some Fortune 500 companies in the US, very closely working together partially. So yeah. It's a very stable technology, and Since recently, it's also completely open source, which was also a big thing for us. Our RAM core is now also completely open source when we introduced the RAM mobile platform. So at the same time, a big change for our core team. Now everything they do is completely transparent, but it was previously very opacly, and they could mess around, and now you can have an eye on it. So what is the RAM database, and what is it not? Let me emphasize what it is not. It is not an ORM. It is the database itself you work with. Even so, you might be used to the very convenient APIs only from ORMs so far from your software development career. With RAM, you're directly interacting with the database. And more specifically, it's an embedded NoSQL object-oriented database, to throw some buzzwords on you. Let's go through that. What does that mean? So embedded specifically means for us that it was built from scratch for mobile. So the founders originally came from Nokia and saw that there's need for something like that. And even like before mobile was back then in the day topic as important as today, they realized it will be more important, and we need something solid technology-wise to build on. And yeah, unlike SQLite, which was supposedly built originally for guided missile destroyers, so the technology is really built for mobile. So what does NoSQL mean? To directly avoid any misunderstandings here, RAM has a fixed schema. It's not schema-free. That would be just too inefficient from our view, especially on mobile with the other hardware constraints. And finally, object-oriented. How does that look like? Let's jump at some code. And disclaimer, this code is in Swift, but it's pretty much the only thing we will see code-wise. So you define your schema directly in code and only there. You don't have any like XC data model or database schema persisted in your database itself. Well, that's there, but you don't have to set it up first. It will be just implicitly derived from your model, from all your model classes, and will be set up for you for your convenience. And how that could look like for Swift here in this case, but it's very similar across the platforms. For Java, you would use annotations additionally. You derive from one common superclass we have in our framework, which is for Swift just called object to keep things simple, as the language is. And then you have your properties in the atomic data types of the language. Here for the person object, we have a string and an integer. You can define the types in Swift, it's a strongly typed language, by setting default values, which you will also need because of the limitations of the language, which doesn't allow us to read out at runtime the type information if there wouldn't be a value where we could derive the type from. And here we have relations, which are also first-class citizen with RAM. You don't have to introduce any foreign key concept, which is not really part of your schema, but artificially introduced. You have really links between your objects. So children points to other persons, an array, basically you persist there, a specific array which we call in Swift list. And you can also have backlinks based on that, where you link to another class, which is reflexive in this case, just linking back to the person object here and querying over the children attribute to get the parents of a person. But you could also do this in other cases, and for basically linking back on any one-to-many or many-to-many link, it's possible. Yeah, well, and then you can just, based on this, create your objects like you would do with any other objects you define in an object-oriented language. And to add them to the database, you make a write transaction and just add them to the realm. And they will be in a specific person table, not completely like unordered. So there's still the concept of table, even so it's no SQLA. Yeah, and that's like the very basics of how realm works. Can I? Oh. When you want to rely on your pointer. Little joke. So you have objects all the way down, even within your database. So more specifically, realm skips the copy. When you interact with the objects, you interact directly with memory map data. All retrieved objects are just pointers to their data. And this has some far-ranging implications. What are those? So modifications, as we have seen already when adding an object, are only explicitly possible within a write transaction. So here we have to do a transaction to add an object. We would also need to do this to delete objects or to modify objects directly. But out of the scope of a write transaction, it basically behaves like a value object. It will always have the same value. Beyond that, you might have came across, and that's also one of the reasons why it is like that, the ACID principle for a database, which I just want to briefly go over here. This looks kind of complicated, like some formalities. You don't even need to understand it in all its detail. Atomicity just means when you have a transaction, it ever goes through or not, all or nothing. Consistency means you go from one valid state to another valid state. There's nothing in between that. And isolation means when you execute multiple transactions in parallel, you can map this to a sequential order of these transactions. It won't influence that you have two transactions in parallel. There is any in-between state. And also this will have some implications to something we will learn later on about the realm mobile platform. And lastly, something you would expect from every database you would especially want to use on mobile is durability, which is also not quite easy to achieve. Once something is committed, it will remain. There's no data loss at any time, even in the event of power loss. Like when your app crashed or when the OS decides to kick your app and doesn't give it any runtime anymore. It can happen. It's not even your own fault that the app will be exited all of a sudden. And a database has to be robust in such cases. We achieve all of this by using... Can we have the light on? Thanks. We achieve all of this by using a MultiVersion concurrency control algorithm. This sounds complicated, but it isn't. But it has some implications on how you use RAM in a multi-threaded or multi-process environment, which I think is, especially with reactive apps and building these, very important. So I want to go a bit into the detail and explain how that works. So a naive mechanism or algorithm would just work by allowing you to read and do several read transactions, which for us they happen implicitly. For other databases, you do them more explicitly by explicitly pulling stuff out of the database and copying them. But all of this is not happening with RAM. And then doing a write, and in this case, you wouldn't allow to do any reads or writes because you would read out, or there would be the possibility that you would read out corrupted or incompletely serialized data. And just once the commit is through and your writes actually happened to the file, then you would allow reads again. But this is not the way we solve this problem. Instead, the MVCC algorithm works more like, imagine like a Git, but without branches. So it also stores partially the history of what you did with your database. So once you do a write transaction, the data is basically forked and you write a new version. And because this fork is happening and the old version is still retained, you can still read from other threads, from other processes. You have one background thread, for example, where you're doing some modifications to the database contents. And once the commit is through, other writes from other background processes can happen if you're like sending multiple network requests, which all want to write something to the database and produce data. But your UI will keep responsive, and it can read from the data in the database. And once this commit is through, the UI thread can update to the latest data and will automatically do so on like all our major platforms. There's a run loop in some way where you can we have some mechanism in place which automatically ensures that the database on the main thread will obviously in the background auto-update it always to the last version. And this is important that something like this is happening to keep in mind. If you spawn a lot of threads and you would spawn more of these intermediate versions, they couldn't be freed up as long as there's still a thread which is stuck at one particular version. And for iOS and Cocoa specifically, there's always only a run loop on the main thread and not on the background threads. You would need to spin them up yourself on the background threads, but mostly it's not worth the effort. You only dispatch like once and do something little, and then you make sure to close the realm on the background thread again, and for the next write transaction, you like open again the realm and close it again. There won't be much performance impact by doing this open and close, as we are sharing data across the threads by handing over the accesses to the memory map file. And on base of that, we can have built-in notifications in the database. Whenever something is happening to your database, you can hook into and wait for specific events. And these are possible on a wide range of granularities. So we have file-wide observations, which seem to be pretty simple. Like even if you would do a very naive approach of implementing your own database, once a file is updated, okay, well, there's something new. But beyond that, you can even have fine-grained notifications on collections. So you can make queries for a specific subset. Let's say like all persons over the age of 30. And only if this specific collection is changed, then you would get an update, and not only that this collection has changed, but also what has changed within this collection. So you would get notified there was a new person inserted, which is 32. There was a person deleted from this collection because it was changed. It was an error, it's 29. And like movements within the collection. So very fine granular, and that helps you a lot with building UIs on base of that, as you can do based on that directly animations and stuff like that. And that's not even the like finest level of granularity. It's even possible to observe individual object properties. So if I have, say, one person and I want to observe just a property name, then I would directly get an update with the name change. Just a little disclaimer here, so this is not fully exposed on our platforms, as we have, meanwhile, 4 platforms. It's been, since then, kind of hard for us to have a feature match or a cross. We are trying, but Cocoa and Java are definitely the most like robust and like oldest platforms we support since the longest time. So they are just a bit ahead feature-wise, while Xamarin and React Native are catching up quite quickly. And yeah, some of these features are just not as easy to implement in some of the language, like in others. For Cocoa, for example, observe individual object properties means, in fact, that ROM objects are KVO compliant. So, and now where we have learned it all about what Realm database already offers, I think we can go a little step further and learn about the Realm mobile platform. So with the Realm mobile platform, we are extending this, what you have available already on the client side to the server side. And this together with synchronization. So a Realm can be now also on the server side, and you can connect it from the mobile client side with just few lines of code. We have even tested it in our example apps ourselves. Just adding the 2 lines of which user should be authenticated. For more sophisticated user authentication, you would need to do a bit more than just doing hard coding an API token for sure, and adding the server URL of your Realm object server. But it's just basically that what you would need in a very, very simple scenario to add synchronization to your app already using Realm. So what does this change for the deployment options you have? We have learned before that Realm is available on a wide range of client-side technologies on iOS and Android. And on the server side, we offer now a Node.js binding. And unless you might expect, we didn't go for the classic SRS business model, but instead, we are giving you the server, and you can just deploy it yourself. So you can use it on your existing infrastructure or on your cloud of your choice. We have some predefined images, like to easily use it from Ubuntu or on AWS. And there's also a developer edition, which is available for free, and you can just run it with a simple app on OS X, for example. So quite easy to use, but what can I do with it? What use cases are there? And step back to what we have seen before. This use case where we have one like client-side ROM and one on the server side could be just device backup already, like as simple as that. But we can even extend this, and it can offer us far more than that. If you have ever come to the scenario that your app is on supported on a phone and tablet, and your users would use it in like different times of the day, say, on a different device, you want to have the data always available at the latest and greatest stand and with everything. And by just using Realm together with user synchronization, user authentication, you can already have that and connect multiple client-side ROMs to the same server-side ROM, and conflicts across these. If I do a change on mobile and have been offline, and then in the evening I'm sitting in front of the TV and have my tablet and do some other changes in my productivity app, and then on the next day I turn on and see on my phone, oh yeah, I wasn't connected to the internet, then conflicts which might have happened in these cases will be automatically resolved and won't bother you, and there will be no loss of data or something. That's something we kept in mind when building this. And so also real-time collaboration will be possible. When we launched that, we had a blog post, and we had a video with a Canvas app where 2 of our team members just have drawn something and even simulated this use case of internet connection loss. And it's really kind of nice, and we are thinking of actually using this for our internal meetings as a replacement for whiteboards, because when you're working remotely, as we do, then it's kind of hard on working conceptually together in such cases, and having like a physical whiteboard on a video call doesn't allow everybody to collect or to contribute in the same way. So something like that would be also kind of nice for us to have, while we are kind of cautious and not duplicating something which was already built, but we are all really into what we have built here and want to try it out to build our own apps. If you go a bit further and really want to go all in, you could even replace your existing backend with this technology. So you can have multiple client-side databases, actually. And one of these could be just private for your user, and another one could be shared across users in a group, like you could use it for messaging. Or it could be completely global and available to all users and only read-only, so that users can get like store locations, something you want to push out to everybody, which is not updating this often and not like really collaborative. And you can have like a wide range of different combinations of all these use cases I've seen before. What would this solve for you if you would go all in, as seen here? You could ban JSON from your apps. Like, this is a problem if you're developing on multiple platforms, because JSON mapping isn't a trivial problem. Who is part of or is developing on Swift knows about this. There are so many JSON frameworks for solving the problem in a type-safe language to map JSON to your objects that, yeah, it must be clear this problem is not trivial. This is not easy. And doing it in a convenient and consistent way across all your mobile apps on all your platforms is already quite helpful in banning the problem completely on the server side. So yeah, just to visualize again, who's not that familiar maybe yet with the problem, you have your model on the server side here again as Swift. Then you have your to serialize that and post something, say, and share data to the server. You have to serialize it to some value. Then you can serialize it to the string representation of JSON, and then you would need to encode it for your HTTP request, and that would be sent to the server over HTTP, which is also not trivial in itself, and would be taken care of by the mobile platform. And on the server, you have to go all the way back. Maybe in Swift, if you're using server-side Swift. But to actually make this possible, to replace the server, you need a little bit more than what we have seen so far. You would also need event handling on the server side. And this is also possible. How could this look like? In this scenario, it might be not as intuitive when you don't have like methods directly you send with the way you interact usually with from. Because what you do is you interact on base of your business logic and make modifications to that. So say we have an app we have built for a sports chain, and we have for their stores coupons. And you want to validate on the app whether a specific coupon is valid. So you create this coupon object with the code, and once it is created, it will be sent to the server. There, it will trigger in the event handling framework the event, and the new code will pop up. It will be processed. You could do whatever validation logic you have. Maybe look it up in a global database where all the coupons which are valid are. This would be for sure coming from a user-specific database where only the user can read and write. And then you would just do a modification to this object and say, yes, this coupon is valid. and this would be synchronized back to your client. You could have notifications for this set up previously for this specific property on your coupon object. And once you get the status change, this could be also optional. So once it is false or it's true, you would get this in your app and could directly update UI from that. And all just with handling with your business logic objects. So the only thing you do is on your app logic is object-oriented programming. So we can extend now our list of the built-in notifications by having a possibility on the server side for observing all realms. And let's dig a bit into how this works. And this is now getting a bit more complicated. So say we have on the client side created this coupon object. Then it will be part of the realm on the client side. And for the synchronization server, here we have like this kind of device environment boundary. We will have, because we did a write transaction and did a modification here, we can derive the actual change and only have to send over the wire or wireless that there was an object created. And this object will be made available on the server side and on the server side realm. And the event processing framework will listen for this specific realm, this specific virtual path, and we'll see, oh, here's a new coupon object. Let's process it. And this one would be here, the processed changed coupon object is indicated by the plus. And also there could be some other objects we don't care about here, or in other realms we process in our way. And we do this modification to the server-side realm. And here again, just the change from this was a dot before, and now it's a dot with a plus, like the delta, would be synchronized back to the client. So it's very lightweight. And you could directly show this on the UI. But also there could be side effects of this. Say in a different scenario, this would be, or there's a customer app for this, or a customer app and app for the one in the store. You could trigger that there is a new object created here. There's a customer which just wants to use this coupon code, and this will be made available to a realm which is shared with the seller and the customer and will be propagated through. And you could also see it like in a different app. Yeah, and so much about the server-side event handling now. And this was already then my talk, and I'm pretty sure there will be questions. Yes, please.
You said about this concept where we can have one realm store on server when we have a public data, and some small stores for user-specific data that are private and are not shared among other users.
Yes.
And like to write to both at the same time. Can you tell us what's the cost of creating these small realms for users? For example, how many we can have them, and what's the, for example, size of simple empty realm? And is it a problem to keep like separate realms for thousands of users?
That's not a problem to keep separate realms for thousands of users. So in general, one single instance of the realm object server is capable to handle already 100,000 connections concurrently, like open at the same time and interacting with data. And you can have even more realms than that. Each realm will store the schema individually, so there's a little overhead there. This is not shared across all like user-specific realms, even if they would have the same schema, but you don't need to set it up on a server side at all. Like you only encode the schema within your object model on the client side. So when you change something, you can do this. You can do additive schema changes in your apps. Then it will be propagated individual for each user and made available then. And even like when a user is on a new app version on his iPhone and has the older app on the iPad, he can still use it on both devices and still actively synchronize data across these, because the schema is handled in a way so that the data can be, that we can still figure out that this data can be still sent to the iPad and is only relevant to that iPad. And this will happen individually for each user. And once like all your user base has updated, all your ROMs will be updated. But until then, you can have different versions across these. But besides the schema overhead, you have ROM in itself is already pretty lightweight, as we have data limitations on the mobile side, and the same will apply on the server side. It's the same core, which is open source, we are using on the server side as on the client side. Any further questions? I'm sorry.
Thank you. Thank you for a nice talk. It was a really nice presentation. I have a question about actually the Android version of this whole framework.
You're welcome, but I'm used to be part of the Coco team at least, so I might be not as knowledgeable as my coworkers from the Android team, but I will try my best to answer your question.
My question is, are you implementing this only in Java, or are you using also native code? Like C,
the
C++?
core of ROM is based in C++, and for Java we are using JNI to make that available to Java, and there is some Java API code, but yeah, it's a native framework.
Any other questions?
What about tests for this framework? I mean, unit tests, stuff like this. It is testable? Do you write any test for it? Do you have any test proposals for this database from mobile platforms? How does it looks like?
It's for a platform or about tests for the REM mobile database?
I think it's for mobile database, for example.
Okay, so for the REM mobile database, I think I can give a very good answer there. Try really hard to test the REM mobile platform and itself already that synchronization works, and did a lot of fuzzing and testing on a high scale to be confident enough to actually ship this product to our users and to enterprise customers. For the ROM mobile database, it's possible to use the ROM in memory and without having it synchronized on file, on disk. And this makes it possible to just set up a database fixture very easily, because you don't have any overhead. You just open up your ROM in memory with your schema, and it will be bootstrapped for you. You don't have to take care of setting the database up, and can create objects and have and test, make modifications to that. And after that, it will be just here down, and there won't be any garbage around. So I think this helps a lot in testing, and that's what we use a lot for our own example apps.
Yeah, thanks.
No questions? Then I want to thank